Okay, so the tool that I chose for my project is the Ozobot. If you can see them, this is Bob, and this is Vader. Hopefully I'm going to be able to use these in my classroom coming up shortly. I chose them. They can be used in a classroom in a variety of settings and across different curriculums. There's two generations of the bots, the BIT and the EVO. Both the BIT and the EVO can perform many of the same functions, but the EVO has more programming options, lights and sounds, and stuff like that than the BIT. They're a little bit more fun. As far as functions and features, Ozobots can cost between $50 and $90 depending on the generation of your bot purchase. The BITs run around $50 and the EVOs run around $90. They also come with really cool little suits. Your kids can decorate them. Bob's actually wearing a suit. Vader's just straight up. Classroom sets range from $1,600 to $1,800 and come with starter packs for projects. They have a tutorial practice book where the kids can practice drawing lines and the stop and start procedures and the different codes for them. They have different templates, kind of little tracks that they come with as well, like this. And they also come with a set of markers. The Ozobots follow lines as well. They're capable of being programmed through block coding in Ozoblockly, which I'll show you later, by the user. And they can follow color-coded marker trails as well, for kids that are a little bit younger. And they can even be driven by the operator from a phone or a tablet. They make it usable and accessible for all different age groups. K3 kids can drive it, from greater than or less than signs, and as you get older, you can navigate the digestive tract. Ozobots can be programmed from a computer, a tablet, and there's even a mobile app, so this could kind of go into the mobile world as well. The Ozobot EVO, and for your bots, the EVO I think works a little bit better with the app than the BIT does. The 4 C's, as far as that, critical thinking, obviously they can be used during instruction to help students develop critical thinking skills. Working with the robots can provide students with an opportunity to construct knowledge through activity, coming from Chambers and others, and scholarly readings. I think Piaget mentioned it too. Students have 3 levels that they can use Ozobots during instruction, so this allows for differentiation, and all the levels require some form of critical thinking on the part of the student. The students develop a knowledge in problem-solving approaches using the new curriculum methods. This is also from Chambers and others as well. Ozobots provide scaffolding for students to progress in their problem-solving skills during instruction. This can also help them with vocabulary acquisition. According to Robinson, if they can think and touch it and do it, it'll be much more likely that they'll remember the different vocabulary. Collaboration. Obviously, the students can work together to collaborate among themselves, work in groups, and have discussions to complete tasks, using solution to problems, and engage in peer-and-peer discussions. And this leads to students having to form explanations to be able to explain what they're doing and why they chose to do so with their new vocabulary. Ozobots are also great for collaboration between teachers and different curriculums. They can navigate the respiratory system in science to discuss how pollution affects the system, and then map the progress of pollution from Europe, across the world, and when they're in social studies. Communication. Ozobots lead themselves to collaboration among teachers and function across curricula. They also can improve communication between teachers when planning activities and lessons. They facilitate communication between students while they're problem solving to reach their learning objectives as well. So kind of across the board, collaboration is reached. Let's see. So kind of for some examples, of course, let's see if we can make this work. Ozoblockly. So we have a programming system that comes up that the students can use to be able to navigate the system with their Ozobots. They can actually use block coding similar to Scratch in order to program their bots. When, if you can see on the screen, they can drive forward, they can have red lights to navigate, which direction they're going, to turn around, to make it change colors with the lights on the bots as they pass through different things. The coding at the top is a lot more complicated. Then the coating at the bottom, the coating at the top, there's actually different levels, level 4, and then down toward the bottom, the 1 and 5 is just very simple things that any of the kids should be able to use. When the kids get ready to program, they can go to Flash, and when you actually get ready to load, the kids can place it on and calibrate the bit, and then they actually hold their Ozobot up to the screen, and it's flashing and programs the Ozobot to do whatever they want it to do, which is pretty cool, pretty simple. So now we have, if you want to have the kids, the younger kids can actually take their bot, if you want them to drive it through the digestive system as you're starting to learn your different vocabularies, it'll follow lines, which it's doing now. The kids can actually draw these, but it's just taking off on the purple, which is pretty cool. Going into the liver, and the kids can label, of course, wherever it's going. Or you can put him up here, and you can actually drive him with your, if you can see it, you can see it on the phone. It's got an app, and the kids can actually drive him through the system, make him spin around. So pretty neat. They also come with different templates. We've used world maps. You can map Magellan's Journey, whatever you need to do. Vader's conflict. Anyway, and they come in really cool little boxes the kids can unpack. They've got little storage compartments for markers and the bot, and they charge on a computer, or you can buy these cool octopus things they charge on. Anyway, this is my new favorite thing, and I hope you enjoyed my tool. Let's see, back to, we can pull that up and it'll actually show us. Gonna work. Or, so, as far as my references, we have this screen. You see it? And I thank you for watching my presentation.